Morning, 6th grade. Welcome to lesson 37. We'll quiz done, I assume. Start with the conversions. We had these conversions on Tuesday. You had a different one yesterday. Back to the conversions today on Thursday. 1 foot is 12 inches, 1 yard 36 feet, 1 yard 3 feet, 1 mile 5,280 feet. 1 centimeter 10 millimeters, 1 meter 1,000 millimeters, 1 meter 100 centimeters, 1 kilometer 1,000 meters. 1 inch is 2.54 centimeters. A pound is 16 ounces, a ton is 2,000 pounds, a gram is 1,000 milligrams, a kilogram is 1,000 grams, and a metric ton is 1,000 kilograms. Next column, 1 kilogram is 2.2 pounds, a pint is 16 ounces, 2 cups in 1 pint, 2 pints in 1 quart, 4 quarts in 1 gallon. 1 liter is 1,000 milliliters. 1 milliliter of water has a volume of 1 centimeter cubed and the mass of 1 gram. 1 liter of water has a volume of 1,000 centimeters cubed and a mass of 1 kilogram. Water freezes at 32 degrees Fahrenheit and 0 degrees Celsius. Water boils at 212 degrees Fahrenheit and 100 degrees Celsius. Your normal body temperature is 98.6 degrees and 37 degrees Celsius. Keep working on these things, guys, to get that memorized, to know your conversions, because you're going to need that obviously coming up on a test, besides all the help it'll give you in math. The mental math section would run something like this. I added, I got $4.65. I multiplied, I got $6.25. Equivalent fractions is 21, or 21 over 24. I reduced it to 3/5. Letter E looks pretty crazy, but guys, just break it apart. Square root of 144 is 12. Square root of 36 is 6. 12 divided by 6 equals 2. Divide by my denominator is 6. Multiply by my numerator. 6 times 3 is 18. What is the next number in the pattern? 3, 2, 5, 4. So minus 1 plus 3 minus 1 plus 3. 3 plus 4 is 7. What number is 5 less than the sum of 5 squared and the square root of 100? So 5 squared is 25. The square root of 100 is 10. Add those together. 25 plus 10 is 35. 5 less than that is subtract 5, gives you 30. The problem solving says 5 arps equals 2 palms, 4 palms plus 2 arps equals 4 dars. 1 palm plus 1 cob equals a dar. 1 arp plus 1 cob equals 1 hilp. 4 hilps plus 3 dars equals 5 cobs plus 7 palms plus 1 arp. Find the value of each item if 1 arp is worth 2. Now, guys, they just gave you made-up words here, and so it drives us crazy. Like, I don't know what any of that stuff means. It's too confusing because I don't know what an arp and a cob and a hom, and I don't know what it means either. But here's what we got here, guys. We got the huge equation they gave us, and then at the bottom they said, I know that an arp is worth 2. So now it's just math class, guys. It's a lot of multiplication, division, and addition. So it goes like this. I stick the 2 in for 5. 5 times 2 is 10. I divide by 2. That tells me this P is worth 5. So a palm is worth 5. Now I'll go over here. Stick my 5 in. 4 times 5 is 20. Stick my 2 in. 2 times 2 is 4. Add that together is 24. Divide it by 2 tells me a dar is worth 12. Over here I have 1, 5 plus 1 C equals a dar, which is 12. So this is 12. So 5 plus, I don't know, equals 12. Missing addition, subtract. 12 minus 5 tells me a cob is worth 7. 1A, which is 2, plus 1C, which is 7, add together equals my hilp. So that would be 2 plus 7 equals 9. Okay, the problem's solved, guys. Now, I could, if I wanted to, go and see if I'm right by sticking the numbers in for this and seeing if they equal that. This is my check mechanism. So I go 4 hilps, so 4 times 9 is 36, and this is 3 dars, which is 12, is another 36. I have 5 C's, which is 7, which is 35. I have 7 P's, which is also 35, and I have 1 A, which is 2. So 35 plus 35 is 70, plus 2 is 72. 36 plus 36 is 72. They check out. Gives me the confidence that I had them all right, even though I don't know what a single one of those words means, guys. It's just doing the math, let you know of sticking the numbers in for the problems that we had. All right, guys, we got a great lesson today as we start working on area of triangles. You've actually done this one a number of times as your book gets you ready for it by making you do certain problems, and we're taking the next step, which is called rectangular area part 2. This is what we call complex area, guys. You get your L shapes and things like that, and we got to be able to figure those things out. Okay, so they're going to work through this, guys. Remember, your example problems go on the bottom down here. To be able to get those things, we have a decent amount to read. It says this: the triangle has a base and a height, and sometimes we use the word altitude. Notice we didn't do length and width, guys. We did base and height. Base and height makes it perpendicular. The base is one side of a triangle. The height or altitude is the perpendicular distance between the base and the opposite vertex of a triangle. Since a triangle has 3 sides and any side can be the base, a triangle can have 3 base height orientations, as we show by rotating this triangle. So guys, they give you a right triangle, and you have base and height. Now they turn it sideways and you have base and height. And then they dropped it from the other diagonal and you have a base and height. So they always have to be perpendicular, guys, and you can give it 3 ways. They'll eventually give you problems that will make you say, hey, these 3 triangles are all the same. How do you find the area with it? If one angle of a triangle is a right angle, the height may be the side of the triangle, as we see above. If none of the angles of the triangle are right angles, then the height will not be a side of the triangle. When the height is not a side of the triangle, a dashed line segment will represent it, as in the right-hand figure above. If one angle of the triangle is an obtuse angle, then the height is shown outside the triangle in 2 of the 3 orientations as shown below. So now they're giving you these triangles, guys, and they're saying we have to drop a dotted line to show you where, because we can't fit it inside the triangle. So they show you how on the left it's outside, in the middle it goes right down the middle, and then on the right it's on the right side. Okay, it says, using a ruler, draw a right triangle, an obtuse triangle, and an acute triangle. Using the method described above, label the base and the height of each triangle, adding the dashed line segment as needed. The area of a triangle is half the area of a rectangle with the same base and height, as the following activity illustrates. So guys, you could do what they ask you and try to draw all those things. As you turn the next page, you can see all that stuff. I'm not going to spend time on it. I'm going to go way to the top of page 267 now, where you have a box. The area of a triangle can be written 2 ways: half base times height, or base times height and then divided by 2. So guys, what I like to do is I like to cut one of the bases or the heights in half and then multiply by the other one. So that would be using the top formula. And I'm not always going to take half a base. It might take half the heights. What I do is I look for an even number. Whatever even number is there for the base or the height, I chop that one in half and multiply it by the other number. It keeps the number smaller and easier to do in my head. Okay, let's work through some of these things. Example 1 says find the area of the triangle, and they give you the triangle and the measurements for it. Okay, so they gave you 7, 4, and 5. Now guys, think about your formula. Your formula is base times height divided by 2. So you only need 2 numbers. And you're going to say, well, why did they give me 3 numbers? Are they trying to make life difficult for me? No, they're not making life difficult for you guys. They leave that in there so they can ask you the perimeter question. So what I always do is with area, I multiply to find area. And how do we show multiplication? Well, one way we show multiplication was a dot. So I always say find the dotted lines. That'll give you the numbers to multiply. So dotted line and dotted line, those are the numbers I'm multiplying. Now I could do 5 times 4 is 20, divided by 2 is 10. But what I was trying to tell you here is I always find this even number. Cut that one in half. 4 divided by 2 is 2, times 5 is 10. Now this one was easy, guys, because the numbers were smaller. But this will come off easier as these numbers get bigger to divide by 2 with one of them. So I got 4 times 5 is 10, 20 divided by 2 is 10. We were working with centimeters, so I got 10 centimeters squared. Example 2. High on the wall near the slanted ceiling was a triangle window with the dimensions shown. What is the area? Well, this one was nice, guys, because they only gave me the 2 numbers. They only gave me 3 and 6. What I did, I chopped the 6 in half. That's 3. 3 times 3 is 9. It's 9 feet squared. Okay? Well, you could do 3 times 6 and get 18 divided by 2. I try to divide first, multiply second. Make sure you cut it in half. But also remember, guys, triangles are the only ones we cut in half. So don't confuse that with rectangles or other things. Okay? Most of your problems in the future will give you 3 numbers at least, sometimes a 4th number. So you have the 3 that are going to be going around the sides so you can figure out the perimeter, and then they'll drop that dotted line for the area. Continuing at the bottom of page 267, we have practice finding the area of rectangles. Sometimes we can find the area of a more complex shape by dividing the shape into rectangular parts. We find the area of each part and then add the areas of the parts to find the total. Example 3. Nate sketched the floor plan of his bedroom. Dimensions are in feet. All angles are right angles. What's the area of the room? So you have an L shape. They gave you the numbers 10, they gave you the numbers 12, they gave you the number 13, and they gave you the number 7. Now you have two choices, guys, when you have this. You can either drop a line vertical or you can drop a line horizontal. It doesn't matter. Both will give you the same answer. Okay, I'm going to show you this. So here's how I do it. I'm going to decide to drop vertical. When I drop vertical, I'm going through this line. So I circle that line. I am not using 13. Because I cut the length of this into pieces. Now what I do is I say, hey, 13 is running horizontal. What else is running horizontal? This 10 is. 13 minus 10 tells me this is 3. Okay, area on the one side is 7 times 3 is 21. Area of the other one is 10 times 12 is 120. Add those two together and you get 141. We are working with feet, so it's 141 feet squared. So I always circle this. Some of you might want to, instead of circling it, put an X through it. So that you say, I can't use the 13 as a 13. Because sometimes, guys, what we attempt to do is take 13 times 7, get a big answer of 140. I'm trying to do that in my head. What 13 times 7 is 91, I think. And right now 91, and then do these two. So always cross it out so you don't get confused. It would be the same answer, guys, if you went this way. We would be adding two different numbers, but they would add up to 141. Okay, example 4 says, find the area to figure out the right dimensions are in meters. All angles are right angles. So they're telling you that so that we know that we can drop our lines the way we drop our lines. Okay, this one looks like this again. And I have 20, and I have 10, and I have 14, and I have 5. Okay, I'm going to draw this one horizontally for you. So going this way, boom, through the 10. It's on a vertical line. This is on a vertical line. So 5, 10 minus 5 is 5. Okay, now I'm using this guy on the bottom. 20 times 5 is 100. I'm using this guy on the top. 5 times 14 is 70. And 100 plus 70 is 170. And I get an answer, and this one I think we're working in meters, guys, so this would be meters squared. Okay, the last thing I want to show you, I'm going to do this problem one more time with you, is another way to think about it depending on the numbers they give you. They've done this to you a few times in your problems, and that would be to go like this. So I'm back to this same L shape, guys, and they gave me this times this. Now the other way to think of it is I can, instead of cutting in half and adding the two pieces that are there, I can think of what are the totals and what could go away. So this would be one where, let's say instead of giving you this 14, 20 minus 14 is 6. They gave you this 6. Even better, instead of saying this 5, 10 minus 5, they gave you these two measurements. I would use the, let's think what's there. The whole thing, if this was a major rectangle, would be 10 by 20, which would be 200. This little guy that we chopped out would be 6 times 5, which is 30. Now this guy is gone, guys, so I don't add that 30. I subtract that 30 because that piece is missing. And 200 minus 30 is that 170. So every once in a while, guys, based on the numbers they give you, it might actually be better to think of the whole and the piece that's missing. Okay, now I want you to think of the future. I just taught you area of rectangle and complex shapes, and we also taught you area of a triangle. So the time is coming, guys, when they can put those things together and give you area of a rectangle and then slap a triangle on it. This is an ugly looking rectangle, sorry. And then put a triangle on it to put them together because you know how to do both of those. Okay, IXL linked some practice with this, guys. You have some numbers, letters there at the bottom of the page and a couple more on the top of the next page. This is a great one to practice on, guys. Your book asks you a lot of complex area problems. They'll review the complex perimeter problems. This is geometry class. This is really good, so get your practice with it. All right, I'll see you for some problems. All right, sixth grade, here we get going on our problems. Before we get going on our problems, you want some extra credit. At the top of your paper, you write down one of Mr. Bauer's favorite movies. Here's your hint to be able to find one of Mr. Bauer's favorite movies. If you look over his shoulder, there's a puzzle on the wall, and the puzzle of the wall has a picture of his favorite movie. Number 2 says, during the 6 months of the year, the car dealership sold all those cars. What was the average number of cars for the first 6 months? So guys, we got to add them all together. You got 47, 53, 62, 56, a 46, and a 48. That's 10, 12, 18, 24, 32. That's 7, 12, 18, 23, 27, 31. Now I take that 312 and I divide it by 6. Goes in there 5 times. Sorry, look at that. I wrote 316. 312. Goes in there 5 times. That's 30. Subtract 1, bring down the 2. Goes in there twice. Labeled 52 cars. Number 5, diagram this statement, then answer the questions that follow. Aziz sold 2/3 of his 16 muffins at the fundraiser. How many did he sell? Divide by my denominator. 6. Multiply by my numerator. 12. He sold 12 muffins. How many did he not sell? Subtract. Total muffins minus what he sold gives me 6. He didn't sell 12 of those, 6 of those muffins. Number 6, what is the perimeter of the hexagon? So you have an L shape upside down. They gave you 7, 9, they gave you 6, they gave you 3. Okay, step 1, what's the top? Horizontal plus horizontal is 15. What's the side? Total side 7 minus piece side 3 of a vertical gives you 4. Now I'm just going to add in circles. Or you can do total plus total and times 2. So 15 plus 7 is 22. Times 2 is 44. And we are working with inches here, guys, so it's 44 inches. Your other choice is add those numbers all around. Number 7 says there are 2 ways to find the area of the hexagon. What are they? And then find the area using both methods. So, guys, one is add 2 pieces. I'll just write that, add the 2 pieces. The other one is subtract the 2. Subtract, maybe you want to say subtract piece from the whole. I'm not going to be able to fit the word whole in here, from the whole. Okay, so I'll show you this now. I'm going to put it on a new screen for us. Here's way 1. They gave you 7, we figured out the 15. They gave you the 3 and the 6, we figured out the 4 and the 9. So one way to do it would be drop my dotted line, circle the 15 because I'm not going to use it. Now, guys, we already found our missing pieces, so the key for us is just pick the right numbers. This guy would be 6 times 3 over here, which would give me an 18 for this area. This would be 9 times 7 over here, which would give me 61. I add those 2 together. 61 plus 18 gives me 79. Choice number 2, the subtraction way would say, think of this as a whole rectangle and what you're minusing out. So that would be taking those 2 numbers would be 24. Taking the big 2 numbers, which would be 105. And I would get 81 here. Now, I hope some of you were saying, Bauer, you wrote down 61 when you took 9 times 7. It should be 63. So there's where I did it, and I got an 81. So good thing I had to show you both of them so I could see how I messed up. Hopefully you guys caught the multiplication thing and got 81. Obviously, guys, when you do it correctly, you will always get the same answer. It's just a matter of, based on the numbers they give you and what they ask you, what can I do the fastest? Do I add the 2 pieces, or can I find it through subtraction? It usually varies, but any way you look at it, guys, the answer was 81. Jumping all the way to number 12. It says write 2% as a reduced fraction. Percent means out of 100. Divide both those by 2. Over 2 gives me 1 over 50. 12b says reduce this number of 720 over 1080. Okay, I'm going to chop by the zeros off. Now, guys, 7 plus 2 is 9, and 1 plus 8 is 9, so I know I can divide by 9. 72 divided by 9 is 8. 9 goes into 10 one time. 9 goes into 18 2 times. So I have 8 twelfths. I got to divide that again by 4. That gives me 2/3. So I reduced it down to 2/3. Was probably faster doing it that way than if we listed all the prime factorizations. Number 15, refer to the triangle below to answer questions A, B, and C. What is the perimeter of the triangle? What's the area of the triangle? So this is a great one, guys, of why they give us all these numbers. They gave me a 15, a 15, and a 18. If I want perimeter, guys, it's on the solid line. So you need 3 numbers for perimeter when you're doing triangles, and they need to be on the solid line. So I'm adding 15, 15, and 18. That's 30, 48. The label would be centimeters. Now notice I didn't even put that dotted line in there yet because I didn't want to confuse you with the perimeter. It's obviously in there for your thing, but guys, dotted lines are imaginary. Perimeter is not imaginary. It's a solid outer surface. Okay, dot means multiply. So I have the 12. The 12 runs in perpendicular to the 18. Now, I could take 12 times 18 or divide by 2. I can't do that in my head, guys. But if I do one of these divided by 2, maybe I can. 18 divided by 2 is 9. And 9 times 12, guys, we just did that one on the last problem. That was my 108 that we got. So I have 108 centimeters squared. So I think that's easier than taking both of these numbers times each other and then dividing by 2. Try to chop 1 in half. And even if you can't do it in your head, 12 times 9 is probably easier than 12 times 18 and then having to do division with that. Awesome. Flipping your answer key over, you got number 16. Number 16 says simplify and compare. So step 1, I have 0.2 plus 0.3. That gives me 0.5. The other side was 0.2 times 0.3, and we might be tempted to say this is 0.6. It's not 0.6, guys. It's 0.1206. So if I want to compare, remember, I want the same number of decimal places, 1, 2. So it's 50 compared to 6. 5/10 is greater than 6/100. Okay, so don't go too fast with those, guys, and get yourself tripped up. Number 17, it says the face of the spinner is divided into thirds. The spinner is spun twice. What are the possible outcomes? Well, guys, there's 3 on the first one. I spun it again, so there's 3 on the next one, which means I need to come up with 3 times 3 is 9 different ones. It's just a matter of finding a pattern. So I spun an A, second time I spun an A again. Spun an A, this time I spun a B again. Spun an A, this time I spun a C on the second one. Start over. Spun a B, A, B, 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 C. Start over. C, A, C, B, C, C. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got my sample space down for A. B says using the sample space to find the probability of spinning A at least once in 2 spins. There's at least one A, 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 and there's at least one A. So for B, I have a chance of 5/9. Make sure you read that carefully. I didn't say spin 1A, it said spin at least 1A. So that first one right here, guys, counts in your list. Okay, the big thing with sample space, guys, is number 1, make sure you get your total by doing the math of 3 times 3, but then come up with a pattern so that you list them all correctly. Number 18. I'm going to do the math as I write it down. 7 times 8 is 56. That equals 4x. Missing a number in multiplication, I solve it through division. So inside the box, out of the box, 1, 14, brings down 16, 4. My answer is 14. 21. Missing the divisor in a division problem, I still divide. So step 1, can I know how to solve it? And then step 2, can I do that? That's from earlier this week when we're dividing by decimals. Make sure your decimal point goes straight up, and I get an answer of 1 and 5/10. Number 22, I'm going to write it as improper fractions as I go. So I have 3/5 times 12 over 1 times 6 times 4 is 24 plus 1, 25 over 6. 5 goes into 25 5 times. 6 goes into 12 2 times. 3 times 2 is 6 times 5 is 30. Number 23, we're adding 5/6 plus 1 3/4 plus 2 1/2. I have to find common denominators of 12. This is times 2 over 2. This is times 3 over 3. This is times 6 over 6. 5 times 2 is 10. 3 times 3 is 9. 1 times 6 is 6. Don't forget your whole numbers. Now I'm going to add 10 and 9 is 19. Plus 6 is 25/12. I'm going to divide. 12 goes into 25 2 times. That's 24. 25 minus 24 is 1/12. 2 plus 1 plus 2 is 5. And I have an answer of 5 and 1/12. 25. Big subtraction. I have 3 and 9/20 minus 1 and 5/12. Common denominator is 60 for this one, guys. So I'm going to multiply by 3 over 3 here. I'm going to multiply by 5 over 5 here. 9 times 3 is 27. 5 times 5 is 25. I bring my whole numbers with it. Subtraction. That's 2 over 60. That's 2. That reduces and equals, guys, 2 and 1/30. 26. Evaluate this expression for A when A is 3 1/3. So guys, they want to slightly confuse you by saying, stick the numbers in there. Okay, that looks confusing to me. This does not. So write it side by side. Okay, improper. 3 times 3 is 9 plus 1 is 10. So I have 10 over 3 divided by 5. I can write 5 over 1. Stays, changes, flips. That goes in there 2. I have a 2 on the top. I have a 3 on the bottom. 2/3. Okay, so don't get confused with making that self look scary. And last is 28. We're supposed to simplify. So they gave me 0.25 times 10, guys, moves it to the right. That equals 2.5. Divided by 10 moves it to the left. That equals 0.025. Okay, so just multiplication, number of zeros is number of times